Right, I think we are ready to start. So hello everyone. Thanks for joining. My name is Marco Calmasini. I'm a product manager with Oracle, and with me is Johnny Safi. Will introduce himself later and will help us doing a demo of the migration, cloud platform migration for with ZDLRA using ZDLRA. So let's get into the. I will do a short introduction first, explain what we will seeing and what it is, and then we will have the demo later. So the when we interacted with many customers over the years, obviously, that were planning and getting ready for platform migration to migrate their databases from legacy platforms to new platforms, and all of them were looking for reliable and repeatable procedures in order not to have to reinvent a custom process for every single database that they had to migrate. They were also considering to upgrade the database version as they were migrating to the new platform. Also to go from a non-multi-tenant, so non-CDB database to a CDB, PDB multi-tenant architecture. Trying also to eliminate or reduce the downtime, and obviously try to reduce the cost of the process of migrating databases. So as a result of this many interactions we had with customers, we developed a tool to simplify the process of migrating from an old platform to a new one. And it's especially useful for large databases, but not only for large databases. Obviously, the big advantage is significant reduction in downtime. It more or less goes down to a couple of hours of downtime, of read-only time, I would say, which is really not even a complete downtime on the source side, regardless of the database size. Tools that supports same endian and cross-endian platform migrations, supports conversion from multi-tenant, non-multi-tenant to multi-tenant, and it's available on through My Oracle support. So you can go and look at the document doc ID mentioned here, and you will find all the details on the tool and the tool itself also. In general, the process works and this way. It's on the left side here on this slide. You have the source database, the legacy platform where you're migrating from. On the right side, you have your destination database where you're migrating to, and Recovery Appliance is in the middle. And the idea is that the Recovery Appliance in the middle becomes a kind of migration engine to help you, through the process. The source database on the left side, it's open in a read-write mode at this time, and we will have only at the end a short read-only window time. But initially you just have your source database. Business as usual, production is open, database is open, application and updating, everything is running normally as usual, and you do your regular backups from this database to the Recovery Appliance. So, okay, the first one, if you never did it, is a full backup, and after that, it becomes an incremental backup only forever. Okay, so the Recovery Appliance will create a virtual full every time you send an incremental backup, and this is one of the typical characteristic of the Recovery Appliance. One of the main features of the Recovery Appliance is allowing incremental forever backup. So again, business as usual. Source database is open, applications are accessing the database, and you do your incremental forever every day to the Recovery Appliance. When you're ready to start preparing your destination database, you do your first virtual full restore. You prepare your target database where you are migrating to, and this is done again through a set of scripts that we provide in order to give you this ability to have a repeatable procedure without, the need of reinventing the wheel every time. And this is done through the restore from platform arm and command, and the database start being prepared, if you want, on the target side and populated. When you are ready to switch over, at this point is where you have this short read only window. So you put your source database in read only mode. You do your last final incremental to the recovery appliance. You restore the final incremental, do recovery, and the little final step is the export and import of the metadata. That's metadata only. It's not a full export, obviously, just metadata. And when this is done, the destination can be opened in read-only mode, just to verify that everything is properly converted, migrated, available, etc. And then you're ready to move on and start open your target database in read-write mode, and your migration is complete. Some of the customers I was referring to at the beginning presented their experience at Open World. So if you go do a search for past Open World sessions, you will be able to find this presentation with all the details. Metro is one of them. It's a retail company in Germany. They migrated 900 databases from IBM AIX to Exadata Cloud Customer using these tools. And again, they were able to dramatically reduce the downtime due to the migration. Energy Transfer is a company based in the US instead that also used the same tool. And beside the different typical benefits that they obtained by introducing the recovery appliance, like faster backups, 48 times faster backup, 5 times faster recoveries, and in general, a more efficient backup management for all the Oracle databases. But those are just the regular benefits that they have just because of they started using the recovery appliance. But they also used this method that I just explained to migrate their databases. And again, they went into more detail. I just have a short, very, very short summary. But again, if you go and look at the Open World site where they presented, there's a lot more detail that they shared. Okay, but they, had to migrate, a number of databases from Solaris again to Linux to Exadata, I think it was. We wanted to use their existing backups to do the migration, and they also had to upgrade at the same time. They went from 12.1 databases to 12.2 databases, trying to minimize downtime for all this migration that had, was a number of databases between 2 and 6 terabytes in size. And at the end, they also had to enable TD encryption. And the process they followed was, this one. And the reason I liked this one is because, as you can see, most of the work was done during regular business hours. Okay? Normally, when customers have such migrations that they want to do, I don't know, doing a full export import of the database, for example, using the more traditional approach, they need to plan for off-hour works. They usually start the Friday evening, and then you keep going until everything is complete. In this case, a lot of the work was done during regular business hours. So all these first initial steps. Step one, right, checking the source side, getting doing the first level 0. So the first full backup restore on the target side, getting it prepared. This is all regular time. Tuesday to Thursday, they did a level 1 restore and just keep doing that for those days until Friday morning. They did another, if you want, final level 1 backup and restore, and start getting up to speed, if you want, or up to the point in time preparing for the switchover on the target side. And then finally on Friday evening, they took their applications down, did the final level 1 backup, the first metadata export, recovered on the target side, and then the final metadata export and import they did a check of the target objects and making sure that everything was copied correctly, or migrated, I should say, correctly, and enabled TD encryption, and they were done. And again, especially when you have many databases, being able to do a lot of the work during business hours is what helps dramatically reducing the cost of the process, and I would also save the well-being and the life of the DBAs involved with the migration, right? The regular export import that they tested took like 32 hours, or more than 32 hours. So again, this would be almost a complete weekend dedicated just to this migration. Using ZDLRA, they went down from 32 plus hours to around 4 hours. 4 hours, it means that they could just do their work on that work on Friday evening, and they were basically done before the night, I would say. Again, this reduced migration cost also, by the fact that there's very okay, so sometimes when doing a migration, the traditional way means, okay, for each individual database, start planning, configuring, migrating, and designing, etc. Sometimes things are not done properly. You have to redo it and go back and change things, etc. Having a fixed procedure like this tool helps in not having to rework, to go back and change things, because everything is already guided, if you want, by the scripts that we make available. The demo that we will see in a moment is represented here. So on the left side, we have two databases running on Solaris. One is a 12.1 database, the one called HRMDB, the other one called FinDB is a 12.2 database. Those are two databases that are regular non-multi-tenant, non-CDB. Those databases will be backed up to the Recovery Appliance, and then the tools will be used to restore them. And the end result will be that we will have two 19.8 databases as PDBs, part of a single CDB. So we will go into Exadata. So we'll migrate to Linux, and we will be in a multi-tenant architecture with two databases, and upgraded to 19.8. So this is what we will be seeing in a moment with Johnny. Johnny, are you ready to take it from here?
I'm here, yes.
Okay, good. So I'm going to stop sharing. You can share your screen, take it from here. If there are questions, feel free at the end to unmute yourself and ask questions. Otherwise, you can use the chat or the Q&A tool, and we will answer them either live or on the tool. Presentation is recorded. It will be posted on the Ask Tom website, so you can go and find and review it at a later time. Also, you can, if you have questions at a later time after this session, you can always post them on the Ask Tom website, and we will try to respond there. Okay. So thank you for now, and Johnny, you can I'm stopping my share. You can take it from here.
Yeah, 1 second, just to prepare this. Okay, so thank you. Do you guys see my screen?
Yeah. Well,
okay.
It says started.
So,
yeah. Okay. Good.
Yeah. Hi, everyone. My name is Johnny Safi. I work on the MAA team.
Okay.
The
Johnny,
maximum.
sorry, 1 second. It's a little, at least for me, it's a little small.
Don't worry about it.
Oh,
Don't
okay.
worry.
Okay. Good.
Don't worry
Sorry.
about it. It's gonna get. I'm gonna maximize it once we're there.
Oh, okay. Good.
So my name is Johnny Safi. I work on the MAA team, the maximum availability architecture, and for Exadata best practices and backup and recovery best practices, ZDLRA. And we're here today to work with actually to present a demo on a cross-platform migration using the ZDLRA going from Big Endian 12.1 and 12.2 databases to a 19.8 CDB. So we're putting the two databases in two single instance databases, and that it can be rack, whatever, into a CDB. So you can raise your hands and you can put stuff in the chat and the QA. So how many of you are going through migration processes from big endian to small endian? Just want to see some hands. Nobody raised any hands, or I don't know, maybe I cannot see them now. Okay, so let me go through this then and just, okay, so this, everybody can see the screen, correct?
Yeah, now it's okay.
Okay, so basically we have a terminal screen on an HR database, one on a finance here. Those are the source databases. And then here we put two additional screens on the destinations. We labeled it just to see them from the PDB level. And this is at the CDB level, and this is on the ZDLRA. So basically, we introduced the screens. This is a ZDLRA. This is an HRMDB 12.1, FinDB 12.2, the HRM FinDB 19.8 container, and we have HRM PDB pluggable and FinPDB pluggable. These are going to be the destination. So basically what we're going to do is we're going to start by taking just checking, okay, where are we, just to show the platform that we are on both environments. And then we're going to show you what's the destination look like. So it's already created, it's already empty and ready to receive the backups that will be brought in from the ZDLRA, and then recovering subsequently and doing a cutoff. So here, an interesting thing. The tool that we use has a properties file, and in the properties file, that is, the tool executes on the destination, and it's driven by this file. And this file, it tells it, okay, look, restore the data files that belong to these table spaces onto which destination. And you have also the configuration parameter for the SBT library, how many channels you want to parallelize, etc. The reason we're putting this in yellow here is because we are doing we're using the tool to do two separate executions, one for the HRMTS and one for the finance. And we did a small work of identifying the GUID, which is the DB create file best for every PDB. So we ensure that the data files are going to each PDB that we need. And the same thing on the finance. You can see them here. Now, first thing first is always you take a level 0 to be used for the migration from each environment. Your ZDLRA is going to be receiving those backups. We're going to be ingesting them. You see that we are running the index backups here for these databases. We have for HR, for finance. Okay. And then once a backup is done, actually here we're going to checking on it to see, okay, is it done? I'm good. Am I virtualized? All good. We're going to go in and say, okay, let's restore the first restore here. So we go in and we do a restore. We're connecting using the VPC user to the environment that we want. And then we say, okay, start restoring the files. We're restoring for PDB1 and PDB2, and we log all the files here, and you will see that it's all the RMAN syntax that we use. And once our restore kicks in, you will see that we have restore tasks on the ZDLRA that have been executed from the destination to be that are running, or they are waiting, or to get in. You restore once and recover as many times as you want. That's the beauty of the procedure. So here it gives you at the end a small summary. How many files I restored or table spaces, what is the size, and how long it took it. And if for some reason it retries, you will see, okay, or I failed, okay. We check why it failed. Now, at this point, what we did is that we restored data files inside ASM. So these data files are not known to this destination database. They're just files sitting in ASM, okay? Nobody knows about them. They are not used. They are not touched. And we're gonna just show you that, okay, what do we have in ASM? So you see here, we have the HR files that we brought in and the finance files that we brought in as well. Okay. Now, we're gonna run some workload just to mimic a normal day of operations. And after a workload is done, we take an incremental backup to the ZDL array. The backup is running. We're going to check on the tasks, and you see here that we have index backup from each database coming in. And then we say, okay, you know what? Let's do the recovery. Note that we are using a recover instead of restore here. And again, you don't need to recover every time you do an incremental backup. You can wait 2 days or after 2 backups, or depends. You're going to always get the last virtual backup that we generated on the ZDL array. Now, the important step that now is the cutoff time. So we have to put the table spaces on the source in read-only mode, because we're gonna do the export data pump of the metadata for the table spaces. We put the table spaces in read-only mode, and we will take the last incremental level 1 of this database. This is the last backup that we take, and we will use to recover, and then do the export data pump and import data pump for the table space, for the transportable table spaces. So this is the last recovery. And here, just to show you each time we run the restore or the recovery, depending on the data files that came in, because if you add a data file to a table space on the source, we will grab it. But we generate for you the parameter file for the export data pump and for the import as well. So if you see here, this file will have to be executed on the source, and we already give you what the name will be, what are the table spaces that you'll be getting, etc. And the same for the finance database. We SCP the file, and we're gonna just do a normal EXPDP, export data pump of using this parameter file. You see, we have we exported the data of the table spaces. We're gonna send the dump file to the dump files to their destination. Now, important, the beauty and the value of this procedure is you do not have a complete downtime because your source is open for read only. And the cutoff time is the time that you're going to be just importing the export import of the table spaces. Now we do the import using the EMP par file that was generated for us. And here we changed, if you look here, we changed the connection to go, this is the HR, we're going to HR. And here we are going to finance. So we're sending each one to his own location. You see? Finance. Once we have this done, okay, we're gonna check the table spaces in their respective PDBs. We have them here. They are all here and available. The last step after we, okay, they are there, all the data files are here, and we just need to put them in read-write. We online them for each pluggable database, and we do a final check to show that everything is available as in and is online. And that is a demo. Marco, back to you.
All right. Yeah, thank you, Johnny. It was very informative. If there are any questions, feel free to unmute yourself. I haven't seen questions on the chat, so I take it was clear enough. But yeah, if anyone has any questions, feel free to unmute and ask. Otherwise, we can yeah, close it.
Sorry, are we just limited by the chat, or we can chat with the attendees as well on the phone?
The attendees are muted, but I think they can raise a hand. Yeah, okay. And there is a QA session, QA tool here. We have questions from Abhishek. It says, does it require a platform level conversion? You want to answer this, Johnny?
I actually wanted to answer Paula because Metro and the other customers you referred to on your slide are clouded customer who migrated from big endian to small endian using this procedure. So yes, they came from bare metal to VM, to DOM use VMs on XSCC. Some of them came from AIX, some of them came from Solaris, and pretty much it's the same scenario that actually the demo that we showed you is a Solaris zone where we're coming from and coming to an Exadata. So yes, it's applicable.
Yeah, unless this bare metal is bare metal in OCI already. Okay,
yeah, but I think she mentioned a clouded customer.
Okay.
Yeah.
Okay. That's fine. What about Abhishek's question about does it require any platform level conversion?
I'm not sure I understand the question.
I probably don't understand either. So Abhishek, can you clarify what do you mean by does it require any platform level conversion?
It's possible he's asking about what part in this procedure do we do the endian conversion?
Oh, okay, yes, okay. So this is in our RMAN scripts. We do a restore from platform. So the RMAN scripts that are generated as part of the migration Avicek and the logs, you can see our syntax. It's open. It's restore from platform. That's where the conversion happens.
Okay.
Thanks, Johnny.
Thank you, Johnny. Abhishek, if it's not clear or if it was not exactly what you were asking for, feel free to, yeah, again, reply there or raise your hand. I can unmute you. Okay. All right. Looks good. We're good then. Thank you, everyone, for attending. Thank you, Johnny, for the demo. And again, you will find the recording posted on the slides posted on the Ask Tom website, so you can go there and download and view this again. Thank you, everyone, and have a good rest of your day.